Let's go and review some things we talked about in our last couple of lessons. We've been working with angles on the Cartesian plane, and we said that to work with trig functions of angles, you have to have right triangles. And Ethan, we don't necessarily have a right triangle when we just have a random angle on the Cartesian plane, but we can make a triangle by drawing a line to the
positive x-axis.
Well, if it's in quadrants 1 and 4, positive x-axis, just in generally the x-axis, right? We always draw the triangle to the horizontal, which means then that our triangle won't always have the actual angle in it. So in addition to needing a reference triangle, Quentin, we also need a reference angle, which we represent with the Greek letter, Chris.
Theta.
Well, theta is the actual angle. For our reference angle, we represent it rho. And so for the various quadrants, rho will change, right? In the first quadrant, you don't even need a reference angle, right? So rho, theta, they're essentially the same thing. Go to the second quadrant, we realize that together rho and theta will complete the 180. But if we go to the third quadrant, the angle actually passes 180. However much it passes 180 is the rho. So again, we're seeing how far past the 180 we went. And then in the fourth quadrant, rho and theta together, class, will complete 360. We said that the trig functions of our various angles change as we go from quadrant to quadrant. In the first quadrant, what's going to be true of every trig function, class?
Positive.
All positive. But in the second quadrant, that's not true. Only, Jamie,
the sine.
and of course, if sine's positive, cosecant has to be positive with it, right? In the third quadrant, Ethan?
Tangent and cotangent.
Tangent and cotangent have to be positive. And then in the fourth quadrant, Quentin? Cosine and secant will both be positive. We were practicing with some of these things in our lesson yesterday. I want you to do, actually, no, we're going to do some of these together here. Number 40 in your textbooks, page 55. Page 55 in your textbooks. Let's take a look at number 40 together. And we were looking at some problems like these yesterday, where we're given one or two trig functions, one or two pieces of information. We need all the trig ratios based on the limited amount of given information. So looking at number 40, we're told that the cosine of theta is 9 over 41. We're told that the sine of theta is negative 40 to 41. Now in these two trig ratios, we know all three sides of the triangle. Class, we know that 9 is the adjacent, 41 is the hypotenuse. We also see that here, by the way, and we know that 40 is the opposite. So when it comes to finding the tangent, the cotangent, the secant, and the cosecant of theta, easily doable. But it's more than just that, because now we have to consider the SIGN of every one of our trig functions. Cosine is positive. ASTC, in which quadrants is cosine positive? Chris?
Cosine is positive in the third quadrant. Second quadrant, sorry.
Cosine. Fourth quadrant. And of course,
and as well as the cosecant.
the first quadrant.
Cosine's
going to be positive. We're just rejogging your brain from what we did yesterday. No homework last night. This is the implication of no homework is people don't remember anything, which is why I hate not giving homework. It's not because I love making your lives miserable, it's because I love you learning. Anyway, that's why I'm a teacher. But anyway, first and fourth quadrants, cosine's positive. For redemption, Chris, where is sine negative?
In the third and fourth.
Good, third and fourth quadrant. So evidently, class, we are in quadrant 4. That's the angle that theta would be. It's a reflex angle that's in the fourth quadrant. Which means if we're in the fourth quadrant, class, tangent will be negative in quadrant 4. Cotangent, secant, cosecant, negative. So we've got 3 negative ratios and 1 positive ratio. Now there's a shortcut we can take for cosecant, class.
Just do the
reciprocal of the sine to get negative 41 over 40. There's a shortcut for secant. Reciprocal of the cosine. Tangent we actually have to think about. Tangent's whatever what? Opposite over adjacent would give me the 40 over 9, of course, with the negative in front, and then that means cotangent, 9 over 40. Remember doing this yesterday. And then we said, well, it's kind of insulting to be given all 3 values. I mean, that's too easy. So going to number 48 now. We're given that the sine of theta is 52 173rd, or 52 to 173. And we're also told that the tangent of theta is greater than 0. Well, starting with how we would have always approached a problem like this, we know sines what over what, class? Thank you, Quentin. Opposite over hypotenuse. And if we know the opposite in hypotenuse class, we can find the adjacent. At your seats, find the adjacent using the Pythagorean theorem. I heard 165, is that right?
Yeah.
All right, others confirming. All right, so we know adjacent's 165, but there's one more question that we didn't have to consider before, and that is what quadrant is this angle? Well, sine, evidently, class, is positive. ASTC, where is sine positive, Ethan? A and S, 1 and 2. And then tangent is greater than 0. In other words, class, tangent is positive. Where is tangent positive, class? 1 and 3. So evidently, this is a quadrant 1 angle. If it's quadrant 1, that means all these other trig ratios have to be positive. I'll leave all of them understood at your seats finish. And checking your answers, how do you do? Good to go? I want you to do number 50, is it 50?
Yeah.
No, dropping down to 56. Let's take a look at number 56 here next. This one's kind of interesting, and we didn't look at one quite like this yesterday. The cosine of theta is 247 over 265. Now, if we just stop there, class, what side are we missing? The opposite, right? Here's the adjacent, here's the hypotenuse. We're just missing the opposite. Go ahead and find that at your seats. All right, so we've got the opposite. Now the other information is kind of unusual. It says that 180 degrees is less than theta is less than 360 degrees. Another way of reading this, class, is that theta lies between 180 and 360. Which quadrants lie between 180 and 360, class?
3 and 4.
Quadrants 3 and 4. So I know I'm dealing with either quadrant 3 or 4 here. Notice cosine is advertised as being positive. Which of these possible quadrants will cosine be positive?
4.
Quadrant 4. So evidently we're dealing with a quadrant 4 angle. Do you see how to read that information? Again, a little bit different than what we did last time. So again, we already know the cosine, but we need all the other trig ratios. If I know I'm in quadrant 4, class, I know that sine will be,
Negative.
tangent will be, cotangent,
Negative.
secant, and cosecant. At your seats, finish out these ratios. Checking answers, getting nods of heads. All right, look at number 57 right beside it. We're told that cotangent theta is negative 20 over 99, and we're told that theta lies between 90 and 270 degrees. Well, first off, if theta is between 90 and 270, class, which quadrants is that?
2 and 3.
Quadrant 2 and quadrant 3. But notice cotangent is listed as being negative. Where would that be true?
2.
In quadrant 2, cotangent would be negative. So when it comes to finding my trig ratios, I know in quadrant 2, class, that, let's ignore the cotangent real quick, sine is? Cosine? Tangent? Secant? Cosecant?
Positive.
There we go. Now, I'm not ready to find them all yet though, because I've only been given the cotangent, which is 1 over what? Adjacent over opposite. So therefore I'm missing the hypotenuse at your seats. Find it. 101. Now we can finish it out. Oh, you didn't write it down on your paper? And checking our answers here. All right, look at number 59. Number 59. What's the given information here in number 59, Ethan?
Tangent area equals -56 over 33.
56 over 33,
3.
okay? And
negative 90 degrees is
less than.
theta is less than 90 degrees.
Well, think about this for a second. Negative 90. With your hand, show me where negative 90 is. Negative 90, down here, right? Here's starting position. You go down negative 90. So here's negative 90. Show me where 90 is. Straight up, correct? Starting from here, this would be 90. So from negative 90 to 90 is which quadrants, class?
4.
4 and 1, technically, if you're going in order. But yeah, 1 and 4. I'm going to say 4 and 1 so I get them in order. Tangent's negative, though. So class? Fourth quadrant. Because in first quadrant, of course, tangent, like everything else, is positive. Tangent's 1 over what? And therefore, we're missing, once again, the hypotenuse. Find it at your seats.
65.
Good, you get a hypotenuse of 65. So at your seats, find the trig ratios. Remember, you're in the fourth quadrant. Any questions on this? Maybe do 3 on your own now. 55, 61, and 63. They're on page 55. 55, 61, and 63. Take just a couple moments to work on that, and then we'll get into our new material.
for 2. There's no pi over 2. Huh?
90 degrees.
90 degrees and what's the other one?
Just a little bit longer to be finishing up. All right, for sake of time, let's go and take a look at these together, starting with number 55. On number 55, the first thing I notice is that I've got sine, which is what over what, Chris?
Opposite over hypotenuse.
Opposite over hypotenuse, which means I'm missing which side?
Adjacent.
The adjacent. What did you get for the adjacent, Quentin? 84 is correct. All right, now that we've got all three sides, the next thing I want to consider is what quadrant am I in? Jamie, I first noticed that sine is...
Sine is negative.
Which would be in what quadrants?
It would either be 3 or 4.
Good, sine would be negative in either 3 or 4, but I also noticed, Ethan, that what's true of the cotangent?
It's greater than 0.
Meaning
It's positive.
positive. When is cotangent positive?
And quadrant 3.
Good, 1 and 3. So therefore, it must be quadrant
3.
How many identified quadrant 3 for number 55? All right, so once we've got that, it's just a matter of assigning your SIGN signs to all these different functions. Of course, cosine's going to be negative, tangent, cotangent, both positive, secant, cosecant, negative, and then your answers, of course, we're given the sign. Cosine should be, negative 84 over 205. Tangent should be positive 187 over 84. Cotangent, positive 84 over 187. Cosine should be negative, secant should be negative 205 over 84, and the cosecant negative 205 over 187. How many got all 5 answers correct on 55? Excellent. Let's take a look at number 61, which was the next one. And again, first I notice I'm given the sine, which is whatever what, Ethan?
55 over 73.
Well, yeah, but sine in general is whatever what?
Opposite over adjacent. Or opposite over hypotenuse.
Opposite over hypotenuse, which means again I'm missing the adjacent, which we found to be, Jamie?
48.
48. Next I notice that sine is listed as being negative, which is only possible, Quentin, in quadrants
3 and 4.
3 and 4. But look at the angles. Now, they gave them to you in radians, but when it says pi over 2, class, that means 90. So 3 pi over 2 would be 3 times 90, or 270. So the angle goes between 90 and 270, which of course includes what quadrants, Chris?
3. Wait, no.
From 90 to 270, it encompasses what quadrants?
1 and 4 says 4.
90 to 270.
2 and 3.
2 and 3, right? Not 90 to negative 90, but 90 to 270. Going around that direction is 2 and 3. But we already said sine could only be negative in 3 and 4, so apparently we're in quadrant 3. Once again, not to be redundant, but once again we're given sine. Once again we're finding adjacent. Once again we're in quadrant 3. Yeah, whatever. All right, so checking your answers then. Since we're in quadrant 3, once again, everything's negative except tangent and cotangent. Your cosine should have been negative 48 over 73. Your tangent should have been positive 55 over 48. Cotangent positive 48 over 55. Your secant should have been negative 73 over 48. And the cosecant negative 73 over 55. How many had all those answers correct on 61? All right, excellent. Number 63. This one doesn't work out quite so nice. We've got the cotangent, class, which we know is adjacent over opposite, which means we're missing the hypotenuse, but it doesn't come out rationally, so we're going to have to leave the hypotenuse as a radical. What do we get for the hypotenuse, class? The square root of 170, and it doesn't reduce at all. Okay, so we've got our adjacent of 11, we've got our opposite of 7, and then our hypotenuse of, well, whatever, square root of 170. We're also noticing that the cotangent is listed as being negative. Where is the cotangent negative, class?
3 and 4.
2 and 4 is where tangent, cotangent would be negative. So 2 and 4. By the way, how do we remember the order of the letters?
Also just take
Okay, just making sure the brainwashing was continuing. All right, and then we're also told that theta is between negative 3 pi over 2 and negative pi over 2. Well, we already said 3 pi over 2 is the same thing, class, as
90 and
270. But it's negative 270. So if we start here and go negative, negative 270 is going to wind up here. And we're going from that to negative 90, which would be here. So we're going from negative 270 to negative 90. So what quadrants, class?
3 and 4. No, 2 and 4.
2 and 3.
From here, which is negative 270, to here, which is negative 90. This is quadrants 2 and 3. Okay, let me help out. Coming over here. Where is negative 270? Negative 90, negative 180, negative 270. This right here is negative 270. Okay, negative 90 is right here. We're starting from here, and we're going to here. Does that make sense? So it's quadrant 2 and 3. Does that make a little more sense seeing it on the graph grid? All right, so quadrants 2 or 3 are my options, which apparently means, class, we're in quadrant 2. So when we go to list out all the trig functions, which we already have the cotangent, coming back over here now.
I was about to remind you too.
Thank you, appreciate it. The YouTube audience appreciates it. So we already have the cotangent. We need to find the sine, which in quadrant 2 will be positive. Of course, cosecant positive, everything else negative. So sine should be, let's see, that'll be 7 over the square root of 170. So 7 square root of 170 over 170, which is obnoxious. The tangent ends, or the cosine ends up being negative 11 square root of 170 over 170. The tangent's an easy negative 7 over 11. The secant is negative square root of 170 over 11. And the cosecant ends up being positive square root of 170 over 7. How many got all of those right?
I didn't get
I
it.
did.
Or we're on the right track, maybe? We've done all the right steps, we just haven't finished it out? Didn't get to it at all?
Missed the signs.
Missed the signs. Okay, does it make sense why it's in quadrant 2 now that we've gone over it? Okay, any questions on this? All right, next section, your notes. There's this big fancy title I want you to write in your notes, and then I'm going to translate it into a little bit more understandable English. But this is the way you'll see this on quizzes, tests. You'll see it in your textbook this way. Reducing a function to the same function of a positive acute angle. Reducing a function, meaning a trig function, to the same function of a positive acute angle. Reducing a function to the same function of a positive acute angle. I want you to circle the phrase at the end, a positive acute angle. Circle that, and then put rho underneath it. A positive acute angle. We're just talking about rho, the reference angle. Then the word to, I want you to write underneath it to put as. The word to, I want you to put as. And then reducing means to make smaller, but it's the angle we'll make smaller, not the function. So maybe another way to think of reducing would simply be rewriting. So underneath reducing, put the word rewriting. So although on quizzes and tests, you'll see it listed this way. Reduce each function to the same function of a positive acute angle. What we're basically saying is rewrite each function as the same function of rho. Makes sense? As the reference angle. So step number one in doing all of this. Step number one, if theta is not between 0 and 360. Step number one, if theta is not between 0 and 360, apply coterminal angle rule. If theta is not between 0 and 360, apply the coterminal angle rule. In other words, get it between 0 and 360. Add 360 if you have to, or subtract 360 if you have to. Get theta in between 0 and 360. Why? Because negative angles are annoying. Okay? Angles that have gone past the full revolution to a second revolution are annoying. I don't want to even think about those. Get the angle between 0 and 360, or one could say between 0 and 2 pi, if we're thinking radians.
So how would you do that?
Coterminal angle rule, you add or subtract 360, add or subtract 2 pi.
Okay.
It's the same thing as 360, it's just radian. Number two, determine the quadrant. Step number two, determine the quadrant. That's going to lead you to do step number three correctly, which is to find rho. Find rho. And here's a good place for us to refresh our memory about rho. Because rho can be found different ways depending on the quadrant that you're in. Remember in quadrant 1, rho is theta. And you don't need a reference angle in quadrant 1. So quadrant 1 angles are happy because we don't need to even bother with finding rho. Quadrant 2, remember that rho we can be found by taking a full 180 minus however much of its theta, and the leftovers is rho. Remember in quadrant 3, rho is however far past 180 theta went, because we're dealing with a reflex angle. So take the straight angle off of the reflex angle, and the leftover there is rho. And then of course in quadrant 4, because together they complete the 360, take 360 minus the theta to get the rho. Another way to put this would be rho, remember, is the angular distance from the x-axis. And this is more of a common sense approach, right? There's the mathematical approach, right? And then there's the, how far away from the x-axis is this? To me, that's a more common sense approach, which is what I like. Remember, of course, that 180, you may use pi instead, and 360 may use 2 pi instead. And depending on whether we're using degrees or radians, we'll be fluent in both. And step number 4, apply ASTC. Step number 4, apply ASTC. And all of this will allow us to reduce functions down to the same function of a positive acute angle. Once you have that down, let's go and do several examples together. Write this down, the sine of 170 degrees. The sine of 170 degrees. That is not an acute angle. That would not fit in a triangle. Therefore, if this were on the Cartesian plane, we need a reference triangle and a reference angle, right? So what we're going to do is we're going to set all of this up. We're going to first of all make sure the angle looks good. Between 0 and 360, class, it looks good. Next, we're going to figure out what quadrant that's in. Well, if we remember 90, 180, 270, 360, it should be really easy to tell the quadrant. Quadrant 2. So in quadrant 2, you're going to take 180 minus this angle to get your reference angle. Or How far from the x-axis is 170 degrees? 10 degrees, right? 180 is right here, it's just 10 degrees away. So rho is 10 degrees. Finally, we need to think through ASTC. In quadrant 2, class, sine is... So what we're going to do now is we're going to rewrite the function. We're going to reduce it to the same function of a positive acute angle. We see sine, we keep sine. And we're going to specifically keep positive sine, but instead of 170, we're going to use the reference angle. Positive sine of 10 degrees. They're exactly equal to each other, right? I'm just changing the way it looks. I'm reducing it down or rewriting it. On your calculators, take the sine of 170, make a mental note, and then take the sine of 10. And of course, it's the same thing. We kind of looked at that the other day. Consider this now, right? This went down the tangent of negative 110 degrees. The tangent of negative 110 degrees. Step 1, make sure it looks good. Thoughts?
No.
It's ugly. Why?
Because negative.
Hate negatives. What do we do if we get a negative angle?
Add 360.
Add 360, what do we get?
250.
250. That's better. Because I can picture where that falls on the Cartesian plane better. Where would 250 fall?
Quadrant 3.
Quadrant 3. Remember, quadrant 3 ends at 270. 250 is not quite that far. So it's still in quadrant 3. Next thing we need to figure out is the reference angle. Well, remember, for the reference angle, you're figuring how far from the x-axis or how far from 180. How far is 250 from 180? 70 degrees apart. So my reference angle is 70 degrees. Finally, ASTC. In quadrant 3 class, tangent is positive. So when I rewrite my function, I'm going to keep the SIGN based on ASTC. I'm going to keep the same function, tangent, but I'm going to keep the reference angle 70 degrees. On your calculators, take the tangent of negative 110. Take the tangent of negative 110. So put a negative 110 on the calculator, then hit tangent. Make a mental note of the value, then take the tangent of 70. And of course, they are the same. Because they're equal, it's just rewritten. So instead of looking like this, which would not fit in a triangle, it looks like this, which could. Make sense? Let's do another one. Write this one down, the cosine of 217 degrees. The cosine of 217 degrees. Step 1, class.
Make sure that's in between 0 and 360.
Make sure it's between 0 and 360. Make sure it looks good.
It is.
It does. All right, next step. Figure out the quadrant. What quadrant?
3.
3 again, right? It's bigger than 180, but smaller than 270. Step 3 is to figure out the reference angle, right? Rho. How far from 180 is 217? 37 degrees. Finally, ASTC. We're in quadrant 3. What is cosine in quadrant 3, class? Negative. So we're going to have negative cosine of 37. ASTC tells you whether you put a positive or negative. The function stays the same, and then we drop rho in place of theta. On your calculators, take the cosine of 217. Make a mental note of the value. Now, take the cosine of 37, but change the sign after you get it. Does it now match what you had before? Questions on this? All right, we're not going to verify every time, obviously, but want to give you a chance to verify a couple. Write this one down, the cosecant.
You can check and see if you got it right by doing that on test quizzes.
You can. Yep. It just takes time that you'd rather use for solving other problems, but you could theoretically. Yes. All right, cosecant, 427 degrees. Thoughts?
Minus 360.
Minus 360. It's too big. When you subtract 360, what do we get? 67. Step 2.
Quadrant 1.
Quadrant 1. Wait, if it's quadrant 1, I'm done. Because what I want, a positive acute angle. Guess what I got? A positive acute angle. I'm done. Questions? All right, write this one down. Secant of 320 degrees. The secant of 320 degrees.
If it's in the fourth quadrant, p equals 40.
Rho. Rho equals 40. All right, it's already good to go. It's in quadrant 4. Rho is 40 degrees. ASTC class.
Secant is in the first.
Four, it's in quadrant 4.
Well, since it's in quadrant 4, what is secant?
Negative, positive.
Positive. So we're going to keep the positive from ASTC. We're going to keep the secant, and we're going to keep the 40 degrees. We're done.
I can see how you get really quick with these.
Yeah, exactly. It's not a long drawn out process. You're just rewriting instead of secant 320, which is gnarly, secant of 40. Write this one out. The cotangent of 115. Cotangent 115. Class, quadrant.
Quadrant 1. I mean 2, sorry.
2. It's bigger than 90, but smaller than 180. Reference angle.
65.
65. That's how far it is from 180. ASTC, we're in quadrant 2, so cotangent is negative. So we're going to have negative cotangent 65. Feel like we're in the groove now?
Yeah.
Got it figured out? All right, excellent. Let me erase these. I'll give you 6 to do on your own. I want you to rewrite the tangent of 125, cosecant negative 220, cotangent of negative 15, secant of 225, the sine of 500, and the cosine of 280.
I have a question.
Mhm.
So, to figure out quadrant, would we go by the negative 220? Or
You add 360 first. You don't ever mess with negatives.
Alright, yeah.
That's why we add 360, so we can spot the quadrant instantly. Where with that, it's like, wait, huh, what? If you take care of it this way, you're never gonna have to worry about it. Remember, in second and third quadrants, how far from 180? In the fourth quadrant, how far from 360? Always comparing the x-axis. For sake of time, pencils down, check the ones you got done. In each case, quadrant, reference angle, ASTC. Quadrant, reference angle, ASTC. Unless it was negative or really big, right? Then you add or subtract 360, and then it's quadrant, reference angle, ASTC. By the way, I normally do the ASTC mentally as opposed to writing it, okay? No reason necessarily to write it, but I'm writing it on the board to help you think that through. You don't necessarily have to write it down. How many got all the ones you did correct? All right, Ethan, which one?
I got them all.
You did get them all? Anyone got all of them done? Okay, a couple of you did. Good. Questions on this?
I do all of it in my head.
All right, tomorrow we're going to work on, well, the only problem is you don't get partial credit if you do that. So that's the only downside. Like, even if you write the quadrant and somehow make a stupid mental error, you at least get the partial credit for having the quadrant or the reference angle or something. So that's the only downside of doing it all in your head. That said, by the in another month or two, we'll be doing it all in our head automatically. So we're going to end up getting there. Radians, we're going to say for tomorrow. Okay, so we'll do this with radians tomorrow. Homework tonight actually is not practicing with this, but practicing with more of what we did earlier in the hour. Page 55. Numbers 42, 44, 50, 52, 54, 58, and 60. So page 55, numbers 42, 44, 50, 52, 54, 58, and 60. All right, have a wonderful rest of your day, and you are dismissed.